Good evening, everyone. We are in the week 8 problem solving session of the NPTEL course, Basic Electrical Circuits. And week 8 is about op-amp and negative feedback. Let me share my screen. Are you able to see my screen?
Yes.
Yeah. So, so we'll start with the op-amp. So op-amp is also called as operational amplifier, but in short form, it is called as op-amp. So we'll start with op-amp. So op means operational, amp means amplifier. So it is also called as operational amplifier. So what it means and how do we represent it? So basically you can consider it as a device and it is denoted something like this. So it has one plus terminal, one minus terminal and one output. So it has one plus, one minus. Say this is V1 and this is V2, then this is V0. So all these voltages are with respect to a common ground. So V1 is with respect to this ground, V2 is also with respect to this ground, and V0 is also with respect to this ground. So now, if this is V1 and V2, the difference between this voltage is VD. So we call VD, which is the difference voltage, is nothing but V1 minus V2, or you can say V plus minus V minus. So it is the difference between the positive terminal and the negative terminal voltage. So when we say op amp, it is basically a voltage controlled voltage source. So this is a voltage controlled voltage source. So the output, so what voltage is controlled? Output voltage is controlled. And which is controlling? The input difference is controlling, not the individual voltages. So this is controlled. This output voltage is controlled. And this is the controlling factor. Okay, so we all have seen if there is a dependent source, uh, then it is dependent on some voltage and there will be a scaling factor. You can call it some constant. Similarly, in the op amp, there is a constant and that constant is called the amplifier gain, which is denoted by AV. So now what happens? Now we'll get V0 is equals to this AV into V1 minus V2. So this is the expression of the V0. So this is getting controlled because the output voltage is dependent on the input voltage difference and there is a constant called AV, which is the op amp gain. So now this can also be represented as a voltage controlled source. So we have one input here and we have the output here. So basically what I can call is this is plus minus VD because this is V1 and this is V2. So now the output side we are having AV into VD because VD is nothing but V1 minus V2. And kindly note that this bottom terminal is not the ground, which is very crucial. There is a common ground. So none of the terminals are ground, but all are with respect to a common ground G and D. I'm representing it as G and D. Again, you know here VD is V1 minus V2. So these are very small basics about op amp. So here we have considered one op amp and we have seen what is the input and output characteristics of this op amp, how they are dependent. And if I want to represent it as a voltage controlled voltage source, because this is voltage controlled voltage source, how I am going to represent. So you can represent the op amp something like this. Say if a resistor is connected outside, I can do the same connection and I can also make any connections that are made for op amp, I can make it here also, and here I can directly solve, because here it might be difficult to analyze because there is this symbol in between. So I can transform this circuit into some circuit where it is easily understandable, or where I can directly apply the knowledge of KCL and KVL without getting confused. So these are some basics of op amp which are common, and no matter in like ideal case, non-ideal case, any case, these are the basics that hold good. Now there can be different instances like op amp is ideal, op amp is non-ideal. What are the differences that are going to come if it is ideal, if it is non-ideal? That we'll discuss. But first we'll discuss about something called negative amplifier, and from here we'll derive things, and then we'll see uh, what is the difference between ideal op amp and non-ideal op amp. So we'll start with something called negative feedback amplifier. And Sar has also discussed how to see whether the feedback is negative or not. That also we'll get into it after this concept. Negative feedback amplifier. Okay. So I hope you are following, right? Who are there in the meeting? Are you following?
Yes, sir.
Okay. If you have any doubts, you can stop me at any time. So we have a circuit something like this. This is the plus, this is the minus, or maybe I'll use a different color, plus and minus also. So we have output here, and we have a resistor divider here, and this is the ground. So this resistor divider is connected to this terminal. Okay, so now we are naming it as Vi. This is plus, this is minus, this is V naught, and this is K minus 1 times R, and this is resistor R. Okay, so now say let me call this as V1 and V2. So now what is V1? V1 is equals to Vi, right? And what is V2? First of all, one thing you keep in mind, whenever there is an op amp, the input current is always zero. So the current entering here is zero, and the current entering here is also zero, because it has high impedance in the internal circuit. That part the will not be discussed in this course. It is outside the scope of the syllabus. But you can remember that whenever there is op amp, let it be ideal, non-ideal, there will be input current zero, because the input impedance of the op amp will be very high. So that part is clear, right? Okay. So now, can you tell me what is V2? V2 is a resistor divider circuit. This is V2, right? So this terminal is V2. Can you tell me what is V2 in terms of V naught? Anyone? This is a simple resistor divider circuit. V naught is the total voltage. V2 is the voltage across resistor. So what will be the voltage? Anyone?
V naught by K.
V naught by K. Yes, you're right. So V2 is nothing but V naught into R by R plus K minus 1 into R. So we'll get V naught by K. So I will first calculate VD, something that I know. So I know VD is nothing but V1 minus V2. So VD is nothing but Vi minus V naught by K. So let us call this equation 1. And I know for an op amp, V naught is equals to gain AV, op amp gain AV into VD, right? Which is V1 minus V2. So this is my equation 2. So from equation 1 and 2, we can solve for V naught. Okay, so what do I have? I have V naught is equals to equation 2. AV into V1 minus V2 is nothing but Vi minus V0 by K. So if I bring V0 on to one side, I'll get 1 plus AV by K is equals to AV into V1. VI basically, VI. So this is VI. So now if I do the gain, which is V0 by VI, V0 by VI is nothing but AV by 1 plus AV by K. It can also be written as K by 1 plus K by AV. So if I have given a circuit something like this with a gain AV, then I can summary I can write as V naught by Vi is equals to K by 1 plus K by AV. So is this clear until this point? How we are getting this? We are easy using simple resistor divider theory, and we are getting the voltage, and we have seen that A naught equals to AV into V1 minus V2. So we are only using that and getting this expression. So it is simple math and very straightforward. If you have any doubts, you can stop me at this point and ask. So this is the gain of the amplifier. So because actual gain is what? AV, but here we have connected a circuit in some manner. So that's why the gain is getting changed, and this is the gain of the amplifier of the circuit that we have considered. So gain of the amplifier. So is it clear until this point, everyone?
Yes, sir.
Yeah. So now I'll give some knowledge about ideal op amp. So this is one important thing. So if I consider ideal op amp, say I'm considering ideal op amp. So what makes an ideal op amp is simple. In an ideal op amp, AV gain is infinite. So if the gain is infinite, then what will be my V naught by Vi? Can anyone tell me if gain is infinite? In the above equation, can you substitute AV to be infinite and tell me what we will be getting? In this above equation, if I keep AV as infinite, what will be my V naught by Vi? Someone has said K. Yes, Roshan Ghosh, you're right. So V naught by Vi will be is equals to K. So the gain of the amplifier is K. So it is independent on AV because AV is infinite. So it depends upon the ratio of these two resistors. So it is K. So this is my V naught by Vi. So now in this case, let us calculate one expression which is Vd, which is nothing but Vi minus V naught by K. Because we have seen Vd is nothing but Vi minus V naught by K, right? Because from the equation 1 we got that. So let me write that same thing from equation 1. So now can you tell me what will be the expression Vd? Because we got this equation, you substitute that in this equation and tell me what will happen. What will be the value of Vd? You can substitute V naught or you can substitute Vi, anything is fine. Can you tell me what will be the value of Vd? Anyone? 0. Yes, Roshan Ghosh, you are right. So we'll get Vd is equals to 0, right? So this is what we are going to get, which means what do we mean by Vd equals to 0? The difference between the voltage is 0, which means the positive terminal and negative terminal are virtually shorted because we are not getting any potential difference. That means there is no potential difference between these two terminals, but we are not shorting. But our math is saying that they are shorted, which means they are virtually shorted. So let us write down the conclusion. Positive comma negative terminals are virtually shorted. And this is for an ideal op amp. So that part is very important. So let me write this in the new page. So we are considering an ideal op amp. So what happens for an ideal op amp? First of all, gain will be infinite. So AV is equal to infinite. So what are the observation that we got? First, we got the difference between the inputs is zero. So difference between the input, or you can say the input voltage difference, input voltage difference, which can also be written as VD is equals to zero. This is point one, and point two is the two inputs of the op amp are virtually shorted, because we are getting VD is zero, which means both are actually shorted, but outside they are not shorted, but internally they are acting like as if they are shorted. So two inputs of the op amp are virtually shorted. Okay. So this is what we are getting. So this you have to keep in mind. There might be a question where they will give an amplifier and they will ask for finite gain, what is the V naught by Vi? So then we'll use this V naught by Vi is K by 1 plus K by AV, because AV is finite. If AV is infinite, then we can say that V naught by Vi is K, because AV is infinite. So there might be questions where they will give some question and they might ask what is the V naught by Vi, which is the gain if it is having finite AV, or if it is having infinite AV, what is the value of V naught by Vi? So is this clear until this point, or do you have any doubts? Before we move on to the next topic, which is how to find the negative feedback, whether it is negative feedback, we'll solve few problems and see how we have to solve. So is this clear until this point? These are very simple and straightforward basics, but if you have any doubts, you can ask, because these are fundamentally important for the concepts that we are going to learn further in this session. So do you have any doubts until this point, or can we proceed further? Hello, anyone? Roshan Ghosh, Bhuvan, Prindu Kumari, Lokesh, Priyanka Patel. Any doubts until this point? Okay, someone mentioned in the chat, clear, sir. Okay, so now let us quickly solve a few problems on this topic, what we have learned. So, yeah, so let us consider this as problem one. Today also I'll be dealing with problems right next to the concept that we have learned, because if we do it at the end, things might be too much to digest. So I'll consider theory solved by followed by problems, theory followed by problems. So it will be effective in understanding and learning how to solve the problems. So this is our problem one for today. So I'm calling it as problem one. So things are very simple. Let me use my own circuit and results. Okay. So control C and control V. So this is the circuit that I have considered while discussing the derivation. And this is the result that we have obtained. So we need not do the same thing again and again. So this is the gain of the amplifier, right? So this is the gain of the amplifier. So I am just using this result in this question. So they have asked again ideal and non-ideal cases. First of all, ideal case is simple and straightforward. So if it is ideal, we have seen that AV is infinite, tends to infinite. That implies how much is my V naught by VA? K, right? We have seen, because here we have checked that if we substitute AV, then we will get V naught by V as K. So now tell me V naught by Vi for ideal case. What will be the value? You see, this is K minus 1R, this is R, this is 3K, and this is 1K. So V naught by Vi is K. So for this given values, what will be the value of V naught by Vi ideal? Anyone? So K minus 1 is 3 and 1 is R. So you can calculate and tell me what will be V naught by Vi, which is K. So for you can correlate between these two and you can get the value of K. So you tell me. So now I have to find K and then I have to substitute here for ideal case. I have for non-ideal case, I have to use this expression. So can anyone tell me what will be the value of K for this configuration if they are denoted as K minus 1 R and R? So Roshan Ghosh is saying 4. Yes, you are right. So V naught by Vi ideal is 4. So this is 4. Now let us do V naught by Vi non-ideal. So I'll write what you have just told. You have told K is nothing but 4. So K is equals to 4. Now V naught by Vi non-ideal is nothing but 4 by 1 plus 4 by AV. AV they have given as A naught, which is 396. So 396. So can you tell me what will be the value of this? Anyone who has calculator, can you check and let me know? Anyone? Can you calculate and let me know? Yeah, so someone has mentioned 3.96. Yes, so it is 3.96. So now I have to check what they have asked. 100 into V naught by Vi ideal minus V naught by Vi. Basically, they're checking how much it is deviating from the ideal case because it is not same, but it is very close. So we have to check what is the value. So can you tell me what will be this value? 100 into V naught by Vi ideal minus V naught by Vi non-ideal. Can you tell me what will be the value of this? 4. Yes. So the percentage deviation. So this is 4% error, you can say. So that much is the deviation if you use non-ideal op-amp. So if that is okay for your application, then it should be okay. So the answer is 4. So that's why they have given some range within which you can enter the answer. And they have said round off the answers to one decimal place. You have to round it off to one decimal place. So you have to write either 4 or 3.9 or 3.8, but not 3.96, 3.95. That will not be considered. So read the instructions and accordingly you have to do. So is this clear? Our first problem of today's session. It is simple and straightforward. We have considered one amplifier, which we have discussed just now. Because we have derived the expression, I am not deriving it again. But you can derive it. It is very simple. We have two equations. VD equal to V1 minus V2 and A naught equal to AV into V1 minus V2. So that is very simple and straightforward. Yeah. Now, we got the expression for non-ideal case. For ideal case, AV is infinite, so it is only K. So for the given uh, circuit diagram, we have seen what is the value of K. K is 4 and R is 1 kilo ohm. So we got V naught by Vi ideal and V naught by Vi non-ideal, and we have substituted, and whatever they have asked in the question to find that value, we have found that it is 4% and we have checked it is also matching. So is this question clear? If that is clear, then we'll move on to similar kind of problem, but it is a little bit tricky. So let us see how to solve this question. So someone has mentioned clear, sir. Okay. So this will be our problem two. And if you see, there are two such amplifiers, not one, but two. Okay. So any idea how to proceed with this? Before I go, I want to see whether uh, you can think of anything. First of all, One by one. Yes, you are right, Roshan Ghosh. We have to solve first the internal one, then we have to solve for the external one. That is very good idea that you have done, but that is for non-ideal. For ideal, we know these things hold good, right? So first, let me take this. So if it is an ideal op-amp, then I know the input voltage difference is zero and two inputs are virtually shorted. So using that, let us see. First of all, current is zero. So this current is zero. So if this is Vi, this is also Vi, right? Which means this terminal is also Vi. Now from the resistive divider expression, can you tell me the relation between V naught and Vi? So first we are doing the ideal case. Can you tell me what will be the expression of V naught and Vi? Because it is virtual shorted only in the case of ideal op amp. If it is not ideal, then they are not virtually shorted. Then we have to proceed with this kind of formula, and we have to do with this way only. So in the case of ideal, I know these two are virtually shorted, so this terminal is also Vi. So now can someone tell me what will be the expression between V naught and Vi? For this resistor divider, you can directly get it, and it is very simple and straightforward. So what will be Vi? V naught by Vi is 3 by 4. Are you sure V naught by Vi? First of all, tell me what is Vi? Vi is 1 kilo ohm by 1 kilo ohm plus 3 kilo ohm into V naught, right? So it is V naught by 4. So now from this I can get V naught by Vi ideal is equals to 1 by, sorry, it will be 4. V naught by Vi, so it is 4. Is that clear, Roshan Ghosh? Yes, sir, clear. So first we have solved ideal case because it is pretty easy and straightforward. Now, before we move on to non-ideal case, you have to keep in mind there are two amplifiers. So first of all, I'll simplify the internal one. So how it came, sir, for ideal. So Lokesh, for ideal, I have told that these two hold good for ideal op amp. Ideal op amp gain is infinite. So these gains that they have given, that is for non-ideal case. If it is ideal, it means it is infinite. So for infinite, one thing we know, the input voltage difference is zero and inputs are virtually shorted. So if this is Vi, then this is also Vi, right? So if this is Vi, this is also Vi, right? So if these two are Vi, because these two are basically virtually shorted. So if these two are Vi, then this terminal is also Vi. So for this resistor divider, I can write Vi is equals to V naught by, I mean V naught into 1 kilo ohm by 1 kilo ohm plus 3 kilo ohm. From there, I am getting V naught by 4. So is that clear? For ideal, it is straightforward because these two are shorted. But for non-ideal case, those two are not shorted. Then we have to use this formula and solve one by one, as Roshan has pointed out. Clear or any queries? Anyone? Uh, Lokesh, is that clear? For ideal case, how we are getting? Yes, sir. Okay. So for non-ideal case, we'll start one by one. First, we have to do the internal one. So I'll let me consider the internal one. So let us go back here to the question and just I'll consider the internal one. Okay. So I'm considering the internal circuit only. So now uh, this this is also very easy, but you see how I am doing, and this is also very pretty. I mean, easy and straightforward. But we should know what exactly we are doing. And okay, so now this is my non-ideal case. So non-ideal case, what will happen? Non-ideal case, I cannot use the virtual shorting property, but I know that this is my V1, this is my V2. Say the difference is VD, and this is V naught, and this is K minus 1 R, this is R, and this is my A naught. I know that V naught by Vi, Vi is basically V1, so V naught by V1 is nothing but K by 1 plus K by A naught. Agree? I have considered only the internal circuit and I am using the knowledge that I have gained. Pretty easy and simple forward. Yes. So now let us substitute here. Can you tell me what is the value of K and what is the value of A naught? A naught I know because it is already given. So what is the value of K? Anyone? K? What is the value of K? K is 2. Yes, you're right. K minus 1 is 1. So K is 2. Let us substitute K. So it is 2 by 1 plus 2 by 396. So can someone tell me what will be the value of this quickly?
1.9.
1.9899. So I have pre-calculated it. So you will get something like this. So now what happens is the entire circuit inside this. So the entire circuit inside this can be replaced by a gain of 1.9899. Right? Because I have calculated the gain of the internal circuit is 1.9899. So let me just use this circuit and let us see what I'm trying to say. What I was trying to say is internally this circuit was there, right? So previously it has two amplifiers, one op amp within the other. So now what I will do is this can be replaced by a gain of 1.9899. Agree? Agree?
Yes, sir.
Yeah. So now what I'm going to do. So now I'll redraw the circuit and I'll draw something like this. So this is my plus minus and this is V naught. Here there is a gain, forward gain, and this is V naught. And here we have a resistive divider circuit. Okay, so this is my maybe I'll use a red color for this so that it will be easy. Let me use a different color inside. Okay, okay. So this is plus, this is minus, this is a VI, this is a V2, and this is sir, can we say gain means multiplying factor? Yes, Roshan Ghosh, it is basically multiplying factor. So this has 1.9899 gain, and here it has A naught equals to 396. So this is my uh, K minus 1 into R again. This is my K into R. Sorry, R, just R. This is my R. So now this is given as 3 kilo ohm. This is given as 1 kilo ohm. So now what is the value of K? K is nothing but 4 in this case. Okay. So now this is my V naught. Right. Say suppose I call this as V naught 1. V naught 1 is not what? A naught into V1 minus V2, right? Say this is V1, right? V naught 1 is nothing but A naught into V1 minus V2. So this is just a gain. I am representing it like this because it is represented like that. So is this clear? V naught 1 is A naught into V1 minus V2 because it's an amplifier with a gain of A naught. The output of this op amp is A naught times the input voltage difference. True?
Yes.
Hello?
Yes.
Yeah. So now if this is A naught into V1 minus V2, then what will be this V naught? So my V naught here is this into 1.9899, right? So my V naught is A naught into 1.9899 into V1 minus V2, right? So now this is my new, I can write this as my new A naught dash because my V naught is A naught dash into V1 minus V2, right? And my V2 is what? My V2 is V naught by K, and K is 4, right? Because there is a gain in the inside. Sir, A naught is 1.98. No, no, no. A naught is not 1.98. A naught is this one. The internal circuit I have replaced as 1.9899. So the output of the first op amp is A naught times V1 minus V2. And then there is again this gain. Basically, this gain is nothing but this circuit. So circuit, this circuit is replaced by this circuit. So the first op-amp gain is A naught, and the second circuit, internal circuit, I have represented as 1.9899. So this V naught one is A naught into V1 minus V2, and this V naught is V naught one into 1.9899. So basically V naught is A naught into 1.9899 times V1 minus V2, and V2 is V naught by K, and K is 4. Sir, then it's 396 times 1.98. Yes. So my A naught dash is 396 times 1.9899. So now if I calculate V naught by Vi using my earlier formula, it will be K plus 1 plus K by A naught dash. So if I calculate this, I'll get 4 by 1 plus 4 by A naught is how much? 396, right? Uh, Let me check. 396 into 1.9899. So can someone quickly calculate this value and tell me what it comes? So now V naught by Vi ideal minus V naught by Vi non-ideal. Can you tell me what will be that value? Again, there is less than a minute, so if this meeting ends, kindly join back. Anyone? Just calculate and tell me that value. Okay, this meeting might end. Let me write the value. It will be 3.979. So if I calculate this value, I'll be getting 100 into 4 minus 3.979, which is 2.1. So if you check the answer, it is also coming to be 2.1. So in this question, do you have any queries? Maybe in the last part, I might go a little bit fast. Again, this meeting will end. If it ends, please join back. Are you getting the same answer? Okay, let me explain this question again. Maybe if you have any queries, then it will be solved. So in this question, we have two gains, right? Internally one circuit is there, amplifier, and outside there is another amplifier. If it is ideal case, it is straightforward because these two are virtually shorted. And from the resistor divider circuit, I can get Vi is nothing but 1/4 times of V naught. So V naught by Vi gain is 4. It is very simple and straightforward. If it is non-ideal case, I have to start from the internal circuit. So basically, I am considering this circuit first. So first I'm solving that circuit, and now I'm considering this entire circuit. So this circuit is there, right? So I want to consider this entire circuit as a normal Vi as input and V naught as output, and it has some gain. So I would like to simplify the circuit and consider it as a gain because it is basically amplifying, right? Vi and V naught, the input to this and output. So I calculated that gain and I'm getting it as 1.9899. So once I get this gain, what I have done is I have replaced this by a gain of 1.9899 because this can be replaced as a gain, right? That's what I got from this initial calculation. So now once I do this, I know for this amplifier, if this output is V01, V01 is nothing but A0 into V1 minus V2, right? Because this is V1 minus V2. Now if this is again, tau V0 is 1.9899 times V01. So we'll eventually get V0 as A0 into 1.9899 whole into V1 minus V2. So now this looks like my new A0 dash because V0 is A0 dash times V1 minus V2. So this is my A0 dash and V2 is this voltage, right? So this, so if I say, so this entire voltage is same. So if that is V2, then this is also V2. So now my V2 is 1 by 4 times V naught. So that's what I have written. V2 is 1 by 4 times V naught where K is 4. So now if we solve this again, we'll get this similar type of expression. V naught by Vi is K by 1 plus K by A naught dash, where A naught dash is the new gain because internally there was a circuit which is providing this additional gain to the already existing gain of the amplifier. So it's like an updated gain. So this is my A naught dash. Once I substitute, I'll get 3.979. So 4 minus 3.979 is, I think, 0.021. So if I multiply with 100, I'll get 2.1. So is this clear, Lokesh? Yeah, clear. Okay, so now we'll move on to another interesting and important topic for today's session, which is how to find the negative sign of an op amp. Say I have given one amplifier, how will I know whether it is negative feedback or not? So this part is very important and please pay attention. It is determining negative feedback of an amplifier. Determining, so maybe I'll use a different color. Determining negative feedback of an amplifier. Okay, so basically in this circuit, what we'll do is we will consider a circuit and then we'll see how to get the negative feedback. So I'm not going into the details and proof. I'll just give you the steps. You just have to follow it. Okay. Say we have one circuit. Say we'll consider the same circuit. Okay. So we have Vi here. This is plus, this is minus, and this is V naught. This is K minus 1 into R, and this is R. So we have this circuit. So if we have such circuit, what we are going to do is say what does negative feedback means. So the feedback voltage, which means the V naught to input. So feedback means something is feeding back. So from where it is coming from the output, it is again feeding back to the input. So basically something that is coming in return. So something that is coming in return from the output to the input, this should have some, this should have some negative. So it is getting inverted. So what we are going to do is, these are the steps that you have to follow. First, we'll remove the op amp and then we will connect a voltage V test at the output. So remove the op amp, remove the op amp. So first we'll remove the op amp and then we'll drive its output by V test and drive its output by V test. This is the test voltage that we are doing. Next, what we'll do is remove all the independent sources. So if there is any source here, VI is there, right? VI is the independent source because it is supplying some voltage. So that we have to make it short circuit. So what we'll do is we'll remove all the independent voltage source. Remove all the independent voltage source. Or I could say independent source because it could be voltage source, it could be current source. We are not sure. Independent sources. Now then we have to find the voltage. Say I have considered these terminals as A and B. So I have to find the terminals. First of all, I don't know whether which is plus or which is minus. So I will determine the voltage VAB. So determine VAB. And it will be in terms of something like alpha into V test. Because it's a linear circuit, it will be linearly dependent on the test voltage that we are giving. So now there will be two conditions, A and B. What is that? In the A condition, we'll get alpha is less than 0, and in the B condition, we'll get alpha is greater than 0. So if it is alpha less than 0, what is it? If it is alpha greater than 0, what is it? So basically what I told in this feedback, so in this feedback, we should be getting something negative. So VAB should come negative, then A will be positive, B will be negative. So what happens? So we'll get A is positive terminal and B is negative terminal. But if alpha is coming positive, it means the terminal should be in the opposite way because it should be negative. VD should be negative basically. VD should be negative, but VD is nothing but V positive terminal minus V negative terminal, right? So if VD is coming to be positive, then it means you are doing V minus minus V plus. So that's why A is now negative and B is positive. So A is negative and B is positive. Right. Basically, what I mean to say is we should get something like this. We should get VD should be negative, which means V plus minus V minus should come negative. Accordingly, we'll decide the terminals. So if it is coming positive, it means the terminals are inverted. If it is coming negative, then it means A is positive terminal and B is negative. So first we are going to remove the op-amp and then drive its output by V test, and then we'll remove all the independent sources, which means here VI. So that we are going to remove, and removing means it will be shorted. So A will be shorted, and then we'll check VAB whether it is coming it as alpha V test or not, and then depending upon the alpha, we'll decide which terminals are positive and negative. So is that part clear, everyone? Hello. Yes, sir. Last but not clear. Okay. So basically, what I'm trying to say is, if it is having a negative feedback, what does it mean? It means at the input side, it should be like a negative feedback from the output. So my VD should be something like minus some constant into V test. So basically, if I am giving a positive voltage at the output, I should get negative voltage at the input when the op amp is removed, because that's what negative feedback, because there will be negative sign at the input. So VD should be less than 0. So if I am getting VAB to be negative, which means VD is negative. So A is positive terminal and B is negative terminal. If I am getting alpha to be positive, what does that mean? VAB is coming to be positive. So I am getting V minus minus V plus, because the positive term means I am doing V minus minus V plus as positive, because my aim is I should get V positive minus V negative should be less than 0. So if I am getting alpha less than 0, which means V plus minus V minus is less than 0, then plus corresponds to A and minus corresponds to B. If I'm getting alpha is greater than 0, when it will be greater than 0? When we'll multiply by minus, which means V minus minus V plus. So then in that case, A is corresponding to minus terminal and B is corresponding to plus terminal. So is that part clear? This is very important because this is where we get confused. So is this okay? Is this part clear? Now I'll take this as an example and see and show you how we are going to get. Okay. So now say first of all, example make clear. Yes, Roshan. So now I'll give an example. I don't know which is positive, which is negative, which we are supposed to find. So first of all, I will remove the op amp, right? So this is my VI and this is my VB and this is my V naught. First I have removed the op amp and this is my K minus 1 times R and this is my R. Now I'll excite this with a voltage V test. V test. And this will be grounded because I have to remove all the independent sources. So now this is my A, this is my B. So now you tell me VAB, VA is 0 and VB if you calculate it will be 1 by K into V test, right? Because it's a resistor divider. Now you tell me VAB is equals to what? Minus 1 by K into V test, right? So it is coming to be less than 0. And what is my aim? My aim is I should get V plus minus V minus should be less than 0. So if it is matching, what does that mean? That means my A is positive terminal and B is negative terminal, right? Because these two are matching. Because VAB is coming to be less than 0 and this is also the same. So both are matching means A is positive terminal, B is negative terminal because that is what I am supposed to get. The VD should be coming to be negative, right? Because my VD should be negative because that's what my negative feedback definition says. Because VD should be negative, which means V plus minus V minus should be less than 0. So if I am getting VAB to be less than 0, it means A should be positive terminal and B should be negative terminal. So from the definition, this is my plus terminal and this is my minus terminal, which is what we are already considering in our earlier conversations and earlier discussion. So did it clear your query, Roshan Ghosh? Please repeat. Yeah. So we are doing step by step. First, I have to remove the op amp. I have removed the op amp and I have connected a V test at the output. Yeah, I have connected a V test at the output. Now I have to remove all the independent source. So VI is connected to ground. So now I have considered the terminals A and B. A and B. So now I have to determine VAB in terms of alpha and V test. So VAB, VA is 0, VB is 1 by K V test, VAB is negative. So for a negative feedback, what does it mean? For a negative feedback, VD should be negative. VD is what? V plus minus V minus should be less than 0. So my V plus minus V minus, so positive terminal voltage minus negative terminal voltage should be less than 0. Then only it means it's a negative feedback in this circumstance. So now in this circumstance, for this to happen, when will it happen? When A is positive terminal, B is negative terminal. Then only these two are the same, right? Because VA minus VB is less than 0 means VA should be V plus and VB should be V minus. So that's why we are saying this. So is this clear? Now, now clear, sir. Okay. So this may be a little bit tricky at the beginning, but let us start with some simple problem and then we'll move on to two op amps. What will we do if we have multiple op amps? So we'll do step by step. We have three steps. First of all, remove the op amp. Okay. Then remove the voltage source. Okay. And in the first part only, when removing the op amp, you have to excite it with V naught with V test. Okay. That we are going to do. So let us see. If you have any doubts, you can ask or you can solve with me also. So this becomes our problem 3 for today. So first of all, I'll remove op amp. So this is my 2K and this is ground and this is my 1K and this is ground. So A and B are removed. Now there is another resistor here and another resistor here. Both of these are connected to V naught, right? So now I have to excite this V naught with a test voltage, V test. So the top one is one resistor divider, the bottom one is another resistor divider. So they have given this as 2 kilo ohm, this as 6 kilo ohm, this as 1 kilo ohm, this as 4 kilo ohm. So now this is my A, this is my B. So the top one is a resistor divider, the bottom one is a resistor divider, right? So now I can calculate VA and VB in terms of V test. So can you tell me what is VA in terms of V test and what is VB in terms of V test? Anyone? What is VA? It's a resistor divider. VA is the voltage across 2 kilo ohm in a resistor divider with 2K and 6K. VB is the voltage across 1 kilo ohm in a resistor divider of 1 kilo ohm and 4 kilo ohm. So what will be my voltage VA and what will be my voltage VB? VA equal to 0.25 V test. So yes. So VA is nothing but 2K by 2K plus 6K into V test, which is nothing but V test by 4. Similarly, if I do VB, I will get 1K by 1K plus 5K into V test, which means V test by 5, right? V test by 5. What is my aim? My aim is simple and it is always the same. I have to get V positive terminal minus V negative terminal should be less than 0. 1 by 5. Yes, Roshan. So now let us calculate VA minus VB. VA minus VB. So what it is? V test by 4 minus V test by 5. So what is this voltage? 1 plus 4K. Yeah, I'm sorry. It is thanks for pointing it out. It will be 1K plus 4K. So it is 1K plus 4K. Yeah. Yes, yes. Yeah, thanks for correcting. Now VA minus VB is what? Can someone calculate and tell me what is VA minus VB?
Sir, positive. It's positive
Positive,
feedback.
right? So V test by it is 20, it is greater than 0. So now I have to map, right? So what I'll do is I'll consider VA minus VB is positive, but I need something which is negative. So I'll transform it into VB minus VA is negative. So now I'll correlate these two. If you see, what I'm going to do is, so V plus and VB are same. And also, if I change the color, V minus and VA are same, right? Agree? These two are now fitting, right? Because I need V plus minus V minus to be less than 0. I don't know which is what. So I have written in terms of something similar. From there, I can get my B to be positive terminal, my B to be positive terminal, because I basically need negative feedback. Then I have to check which terminal should correspond to what to get that negative feedback. Yes, sir. VA negative and B positive. So it means if I go back, VB is positive and VE is negative. So now they're asking determine the negative terminal of the op amp. So in this scenario, what is the negative terminal of the op amp? A or B? Hello?
Sir, negative terminal.
A.
Yes, sir.
A. Yes. So let us go and check. So the negative terminal is A. So they are asking which is the negative terminal. So now if you see, it is not so straightforward. It depends upon the resistors and how you are connecting. If I change these resistors, I can make it in a way that A should be a positive terminal for it to be a negative feedback. Because if you see, I got VB minus VA as a negative, but I can play with the resistors and I can make it in such a way that VA minus VB is less than 0. So you have to see there is nothing straightforward. You cannot say that if I connect in this way, it is always negative feedback. I cannot say because it depends upon the resistors and their values and also the way they are connected. So we can never say that I cannot directly say if I am connecting something to the negative terminal, then it is a negative feedback. Because if you see here, something is connected to positive terminal also, but that did not make it positive feedback. It dependent on the way it is connected, because for this same connection I can make it a positive feedback. If I interchange these terminals, I can make it a negative feedback in this type of scenario. So you cannot directly say, or you cannot look at the circuit and say this is negative feedback, that is positive feedback. We have to perform this test and see how we are getting. If v plus minus v minus is coming to be negative, then it is negative feedback, else it is positive feedback. But in this question, the question is different. What should be the terminal? How should the terminal be connected to make it negative feedback? So we have to rearrange the equation in a way that it will look something like this, and then we'll correlate which is positive terminal, which is negative terminal. So I hope this is clear now, this problem, or do you have any further queries? Clear? Yes, sir.
Yes.
Clear. Yeah. So now this is one simple and straightforward question, because it is one op amp and it is the same. So what will I do if I have two op amps, right? Then it becomes little bit complicated, because I neither know whether this is in negative feedback, or I don't even know whether this is in negative feedback. So how we are going to tackle such problems? So let us solve. And these problems are circuit is scary. Yes, yes. Yeah, Roshan. Circuit looks scary, but once you start solving, it will be not. So the best part with the op-amp is, like no matter how complicated the circuit is, you can solve simply by considering it as an ideal op-amp. And when it is ideal, the voltage input terminals are shorted. So that makes it very, very simple. So this is problem 4. Actually, here in our college, I take one lab, Signet lab. So in that Signet lab, there are two experiments. One is negative impedance converter, and one is gyrator. So I was thinking whether I'll make a video and show, because that gyrator circuit is very complicated. It also has two op amps and lot of resistor circuits. But if you see and solve it using this knowledge of the input voltages are virtually short or virtually ground, it becomes very simple, and then you will understand the concept better, because in the experiment it's all about getting the results and see whether it is fitting the concept or not. But we should also correlate whether that concept that we are applying, how we'll reach that condition and everything. So with the open circuits, you should always do in this circuit. And also in the other experiment that I was talking, negative impedance converter, there also the circuit was something like this. The voltage is connected to negative terminal, as well as the voltage is connected to positive terminal. But in that case, how will I know whether it is negative feedback or not? We have to perform this test and then see how the positive and negative terminal should be connected, and then how it has to be like connected with whether it is a negative terminal or positive terminal. According to that, it will be a negative feedback. So now in this case, first we have connected the circuit and we have seen which terminal should be what to make it negative feedback. So in that way we can connect, and then we can do. So let me see, if I get time, I'll make a video on that NIC and gyrator, and it will be interesting. Maybe I'll make two separate videos. I'll see if I get time. I was interested to make, because that is one interesting circuit. So this is my problem 4. So this is multiple op amps. So when I have multiple op amps, first you have to, the steps are simple. So when we are considering individual op amp, we know the steps: apply voltage, V test, and then remove the sources and as well as the op amp, and see what is the voltage that you are getting at VAB. Okay. So now if you see here, there are two independent sources. One is V1, one is V1, one is V2. So both will be grounded. But in the case of multiple op amps, first you consider one op amp. So we'll consider one op amp, which means we'll remove one op amp. Output will make sure that the output is excited with a test voltage V test, and then we'll see the input terminals. So when you consider one op amp, uh, you remove that op amp and excite its output voltage with a test voltage V test. Okay. So now the second point is the same. Remove all the independent sources. Remove. Removing means voltage will be shorted, current will be opened. Remove all the independent sources. It could be voltage source, it could be current source. Now the third point. So the third point says there are other op amps in the circuit, right? Assume that they are in the negative feedback. Okay, which means they are you can consider ideal op amp and negative feedback, which means they are virtually shorted. So you have to consider that other op amp is in the negative feedback. So consider the other op amps are in negative feedback. So we'll assume negative feedback and then prove whether this op amp is how this op amp should be connected to make it a negative feedback. And then once we get the terminals of this, then we'll apply the same for the other op amp. So basically, what does it mean that this is in negative feedback? It means they are virtually short. It means you have to apply the virtual short concept. So you'll consider the other two terminals of the uh, like input side of the other op amp will be basically shorted. So first we'll consider op amp 1, and then we'll assume that op amp 2 is in already in negative feedback. So these two terminals are virtually short. So is that clear? We'll do one by one. Maybe then you'll get the idea. So first of all, I am considering op amp 1. So OPA 1. Sir, please explain last point. So, so what I'm considering is first I'm considering or applying the test for op-amp 1. So what I'm going to do is I will assume that OPAT is already considered in the negative feedback. So when it is considered in the negative feedback, what happens? A and B are virtually shorted. So I'll consider these two terminals are virtually shorted. That assumption I will make, and then I'll check what are the terminals of A and B for it to be a negative feedback. So that assumption I am making, considering I know the terminals of this and this is connected in the negative feedback, and that's why these two terminals are shorted. So I assume that without knowing these terminals to find out the terminals of A and B. So once I know these terminals, then I'll apply the test for this because now I know how this needs to be connected to be in the negative feedback. Okay. So op amp 1. So first I'm going to remove the op amp 1. So VA is connected to ground and VB is here and V naught is here. Okay, so this is my terminal A, this is my terminal B, and the output is something like that. So now let me consider the rest of the circuit. Here we have 1K, here I have another 1K, and here I have one op amp, which I am assuming that it is already connected in the negative feedback. Okay, this is my terminal A. Terminal B is anyway grounded. And then here we have 2K and this is V naught. And I am exciting this with the test voltage V test. Okay. So now I have to calculate VAB. I 8K, 2K, 1K, 1K. So This is 8K. Sorry, I think this is 1K. This is 1 kilo ohm, 1 kilo ohm, 8 kilo ohm, 2 kilo ohm. So what is the assumption that I'm making? Assumption that I'm making is it is virtually short because this is already in negative feedback. So if this is ground, then this is also ground, right? So this is also connected to the ground because I am assuming that it is already in negative feedback. Even though I don't know the terminals, that is the assumption that I am making. So is this part clear? Hello? Yes, sir. Okay.
Yes.
So now, uh, if this is ground, if this is V test, first of all, we also know that current entering the op amp is zero. So whatever current that is coming here, it will also flow here. Agree? Agree? Yes, sir. Okay. So first of all, what is the current flowing in this? It is V test by 2K, right? Because this terminal is grounded and this terminal is V test. This terminal is grounded, right? So this is ground. So voltage across it is V test. Current is flowing from V test to ground. So current is V test by 2K. So if that is V test by 2K, this also should be V test by 2K because it is the same current that is flowing. Agree? So now let this voltage be some V V1. So now what will be the voltage V1? V1 is nothing but 0 minus 8 kilo ohm into V test by 2 kilo ohm. Agree? Or do you have any queries? Yes, sir. Okay. So if you have any queries, please stop me. So now V1 is what? V1 is minus 4 times V test. Okay. Can you tell me what will be VB in terms of V1? What is my VB? VB is what? Anyone? What is VB in terms of V1? So this is my VB. So this is my VB. So VB is nothing but V1 by 2, right? Because it's a resistive divider. Agree?
Yes,
Yes.
sir.
Yeah. So now this becomes my minus 2V test. So now let us gather all the things that we got. First of all, VA is 0 and next of all, VB is minus 2 times V test. Okay. So now what is VAB? VAB is positive or negative? VA minus VB. Hello?
Sir, positive, sir.
Positive. Okay. But actually, what do I want? I need something like this. I need V plus minus V minus should be negative. So from this, I can write it as VB minus VA is negative. So if I do the mapping, V plus is corresponding to VB and VA is corresponding to VA. So I can get the terminals as B is my positive terminal and A is my negative terminal. So let us go back and write uh, B is my positive terminal, A is my negative terminal, which is what we got, right? Agree? Understood? Or maybe it would be good if I repeat. So whenever there are multiple op amps, we should consider one op amp at a time. So that op amp which we are considering or for which we are trying to get the terminals, remove that op amp and excite its output voltage with V test and remove all the independent sources. So short the voltage source and open the current source. Now, what about the other op amps? We'll assume that other op amps are in negative feedback. Even though we don't know the terminals, we are free to assume that other op amps are in negative feedback, which means their input voltages are virtually short. So now using this condition, we have to find VAB, and we have to see whether it is positive or negative, and we have to modify it into that kind of format where we'll get V plus minus V minus is less than 0. So now if we correlate, we'll get VB is positive and VA is negative. So B is positive terminal and A is negative terminal. So now I got the terminals of op-amp 1, and I know how it needs to be connected so that it is in the negative feedback. So now I got for OPA1. Now I'll do the same test for OPA2. So now I need not assume anything for OPA1 because I already know how it needs to be connected to be in negative feedback. So now I'll use this circuit for OPAMP2 to find out what should be the terminals of OPAMP2 for it to be in the negative feedback. Makes sense how I'm solving? But sir, we have assumed second op-amp polarity, so how it justifies the result? I could have assumed the other. See, if you see, very good question. If you see, I have not assumed any polarity of op-amp 2. I have not assumed any polarity. Without polarity only, I have continued. But I have assumed that it is in the negative feedback. Irrespective of my knowledge about the terminals, I have assumed that the op-amp 2 is connected in such a way that it is in negative feedback. So it is connected in such a way that it is in the negative feedback. I don't know whether this is minus or this is plus, but I have assumed that it is connected in that particular way where it is connected in a negative feedback. So I am assuming that it is connected in the negative feedback, and then I am using that knowledge to find my AB terminal. So I have assumed that this is in negative feedback, which means they are virtually short. I am not assuming that this is plus or this is minus. I am just assuming that it is connected in negative feedback. So now I have to find out how it needs to be connected to be in the negative feedback. So again, there is less than a minute. So if this meeting ends, kindly join back. So did you understand, Roshan Ghosh, that last point? I am not assuming the polarity, but I am just assuming that it is in negative feedback. Now my aim is to find out how it needs to be connected to be in negative feedback. This meeting will end. Please join back uh, if we have if this session ends. Please join back. Yes, similarly we can assume first op-amp as negative feedback. We'll get there. We can see. Okay, I'll continue this once this meeting ends. So I'll address your query. There is less than a minute. This meeting will end soon. Any other queries? Anyone? So we'll get back to the question what Roshan has asked. What if I consider op-amp 1 to be already in the negative feedback? First of all, we got the terminals, how it needs to be connected to be in the negative feedback. But without using this, I will solve and I will show how it can be done. So now we are doing for op-amp 2, right? First op-amp 1 we have done. Now we are doing for op-amp 2. So now I'll consider my op-amp 2 and I'll see how it needs to be connected to make it negative feedback. First of all, assuming that I don't know any information about op-amp 1, I don't know the terminals, but I will assume that it is connected in the negative feedback so that virtual short concept is still applicable. So my VA is connected to ground, and then I don't know the terminals, and this is the output, and this is the input. So this is 1K, and this is also 1K, and this is the output where I'll be exciting it with a test voltage V test because I am testing it for op-amp 2. And now as this is disconnected, we have a resistor here 8K connected to the terminal A, and B it is connected to voltage source, so it will be shorted. Now this is my 2K which is connected to the output of the first op-amp. So now let me draw. So first of all, this is 8 kilo ohm. This is 2 kilo ohm. This is 1 kilo ohm. This is also 1 kilo ohm. So this is my terminal A. This is my terminal B. So is this clear, Roshan Ghosh? I have not assumed anything, but one thing I am assuming that this is connected in the negative feedback. So this is already connected in a way in some terminals, like A is maybe connected to positive or negative, I don't know, but I'm assuming that it is connected in that way that it is a negative feedback, which means it is virtually shorted. So this terminal is also ground. Clear? That is my assumption. That is my only assumption. Yes. So now if this terminal is ground, this terminal is also ground. So there is no point of this 1K because both the terminals of 1K are shorted. Agree? Yes. Yes, sir. So now you tell me how should I proceed with this question? This is my VA and this is my 8K and this is my 1K and this is connected to the ground. Any idea? Any how to solve? So now you know that VB is negative. I mean VB is already zero. So my VB is already zero. Okay. So this terminal is V test. VA equal to 10 by 11 V test. How did you get it? VA is 10 by 11 V test. No, sir. Okay. So can anyone tell me in this problem how we can proceed further and how we can solve? Any query? I mean, any suggestions, any idea how we can solve?
Sir, VB is negative, so VA will be positive anyway. VB is zero, so VB is zero, so
Okay.
VA should be positive in any way.
How can we say that?
Uh, Difference is positive, sir.
Like how
VA
can you
minus
say
VB.
VA is positive? Like any logic that you are using here?
Sir, as VB is zero here, so VA should be pos
V, VA can be positive,
because
can be negative also, right?
uh,
Any idea or anything that you'd like to add? Others? Anyone? No, sir. Okay, so VA is equals to zero. How, Fagim, how are you saying VA is zero? VB is zero. Yeah, VB is zero, but VA is something we would like to find. Okay. So what happens is the op-amp output, it should always supply some current, right? So the first op-amp, it is having some current in this direction. Some unknown current, we don't know, but there is some current I naught. Okay. So the current is flowing in this way. And if this is V test, if this is ground, the current flowing in this will be the current flowing in this will be how much? V test by 1 kilo ohm, right? V test by 1 kilo ohm. Agree?
Yes.
Yeah. So now I know that my VA here in this case is V test plus some unknown current I naught into 8 kilo ohm. Right, because this is V test and VA is at a higher potential because current is flowing in this direction. So I need not know the exact value, but I can say this is a positive because V test is positive and I naught is a positive current because op-amp current will be always towards the load. It will not draw current from the output. So that is something that we have to consider here because it is always delivering the current. Okay. So now if you see my VA minus VB is greater than zero, right? But how do I need? I need something like this. My Agenda is always simple. V plus minus V minus should be negative. So I'll reframe this something like this. VB minus VA should be less than 0. Okay. So now let us see. This is my positive terminal, and for negative terminal, this is my negative terminal. So now you know my B is positive terminal and A is negative terminal. So let us go back and write that B is positive. So B is positive and A is negative. So even if I know that here the terminals of AB, what additional thing benefit I am going to get? I'm not going to get any additional benefit, right? I am anyway considering these are virtually shorted. So that is our assumption. Without knowing the terminals, we are basically considering that this is already connected in negative feedback, because this is minus and this is plus. So this is minus and this is plus. Even without knowing the terminals, we are assuming that this is in negative feedback. So we are basically assuming that the circuit is connected in the negative feedback, and now we are finding out what are the terminals. So we are assuming the circuit is already in negative feedback, and now we are assuming that condition, and we are using that result. What is that result? They are virtually short, and then we are using that condition to find out what are the terminals, which is positive and which is negative. Is that clear to everyone? How we have done this? So we are considering one op amp at a time, and then we are solving individually. We are not assuming the terminals. We are just assuming that it is negative feedback. So there is slight difference. We are not assuming the terminals. We are assuming that it is connected in a right way so that it is in a negative feedback. So now we are going to address the questions one by one. So first of all, we have not calculated alpha beta. I'll get this now, but first we'll see how it needs to be connected to be in the negative feedback. So determine the negative terminals of the op amps. OPA1, what is the negative terminal? OPA1 negative terminal is A, right? So OPA negative terminal is A. So A is the negative terminal of OPA1. And what is the negative terminal of OPA2? It is also A. So negative terminal of OPA2 is also A. So is this clear until this point? Or do you have any queries? These two questions, we'll get
Yes.
back to this question. Okay. So now they're asking V naught in terms of alpha V1 and alpha V2. So now I know the negative terminal, positive terminal, everything. Now I'll use this knowledge to calculate V naught in terms of V1 and V2. We know in both the cases A is negative. So let us use that result. So this is
Sir,
minus.
do we have to calculate separately for the both of the op amp, or one verification can give the result for both of them?
For
Like we have done it for two
yes,
cases, so
yes.
for this question we have to do twice.
Yes, yes, because for this op amp, I don't know the terminals. For this op amp, I don't know the terminals. So for doing this, I'll assume this is a negative feedback, and for doing this, I'll assume this is a negative feedback, because I cannot directly say that this is minus, this is plus, right? Because I don't have any valid point to say that. So I have to prove it mathematically. So I have only, but I have the right to assume that this is already connected in negative feedback, even though I don't know the terminals. I can assume that it is connected in negative feedback. I don't know the terminals, assuming that I am seeing what is my A terminal, what is my B terminal, and I'm getting in this way. So now I know how this needs to be connected to be in the negative feedback, but I still don't know how this needs to be connected to be in the negative feedback. So again, I have to find out the terminals. So I have to again do the same thing, and I'll proceed. But for calculating, I need not know which terminal is what. I just need to know that it is negative feedback, so that virtual short thing happens, and I can still proceed for calculating V naught in terms of V1 and V2. But I was asked what is the negative terminal. So for that, I have to do it individually. If there is another third op amp, and if they're asking for that, then again I have to do that for third op amp, assuming these two are in negative feedback. So that part we have to do, and we cannot like skip that part. Is that clear?
Yes.
Okay. So now in this question, they are asking what is the value of V naught. Now we know this is in negative feedback. So this is virtually shorted, and this is also virtually shorted. So now what happens if it is virtually shorted? So this terminal is, I'm sorry. So this terminal is my V1, right? And similarly, this terminal is my V2. And if you see, current entering this is 0, and similarly current entering this is 0. Okay, so whatever, so I'll show the direction of current using a different color. So from this terminal, current is flowing in this path, right? The current should remain same. Agree? In this path, because there is no other path for the current to flow. Simple. And similarly, here also, this is the path of current. From this point, this is the path of current, right? Because there is no other path. But you can not assume this. There will be some finite current here. This is not equal to 0. Op-amp output current is finite. I am not assuming that. I am assuming from this point, the current will flow in this direction. So that makes sense. Is that clear? And let us assume this voltage to be some V unknown. So some V dash. Okay. Any doubt until this point? Yes, sir. Clear. Okay. So now V1 is equals to 1K by 1K plus 1K into V dash. That implies V dash by 2. So now I can write V dash is nothing but 2 times V1. Simple, straightforward, right? Or do you have any further queries? Okay. So basically, I am drawing the expression for this. Sir, what are we finding? So I need V naught in terms of V1 and V2, because in the question, they're asking what is V naught in terms of V1 and V2. So I have to find the relation between V naught and V1. So I know I will get two equations. Here the current, this is the direction of current from this point to ground. So V dash by 2 is nothing but V1. So V dash is equals to 2V1. And here this is the path of the current. So I will apply KCL here. So now if I use this equation and apply KCL, I will get something like this. So I will assume the direction of current is something like this. So V0 minus V2 by 2 kilo ohm is equals to V2 minus V dash by 8 kilo ohm. Agree? So this will get cancelled by 4 times. And if you substitute this in this expression, I will get 4, I mean V0 minus V2 is equals to V2 by 4 minus V dash is what? 2V1 by 4. So now I will get V0 is equals to minus V1 by 2 plus V2 5V2 by 4, right? Agree? So now they have given V0 is equals to alpha V1 plus beta V2. So I'll get my alpha is minus 0.5 and my beta is 1.25. Agree? Basically,
Sir, can you repeat again, sir?
yes, yes. So in this, I need V naught in terms of V1 and V2. So first, I know that if they are in negative feedback, it is virtual short. So this one is V1 and this one is V2. And I also know the input current of the op amp is 0. So if this is 0, this is the direction of current. And similarly, if this is 0, from here, this is the direction of current till this point. Okay. So first I have applied KCL at this point and I will get V1 is equals to V dash by 2. Or you can apply resistor divider. So V dash is across 1K when there are two 1K resistor. So V1 equal to V dash by 2 or V dash equal to 2V1. Similarly, if you apply KCL at this node, current entering is V0 minus V2 by 2K and current leaving is V2 minus V dash by 8K. So now if I substitute V dash equal to 2V1 in this equation and do simplification, I will get in terms of like V1 and V2, where alpha is minus 0.5 and beta is 1.25. So now let us go and check. Alpha is minus 0.5 matching and beta is 1.25. So they have asked to round it off to two decimal values. So I'll write 1.25. If they ask it to round it off to one decimal value, I'll write either 1.2 or 1.3. Both will be correct. So is this clear? This question? So this question is a little bit lengthy, but if you see how many marks it carries here 1 mark, and 1 mark. So this question itself carries 4 marks because it has a lot of conceptual knowledge that is needed, and that's why it carries around 4 marks. Sir, how can we consider both op-amp as negative feedback given in the question? So basically, whenever any op-amp circuit is given, it should be connected in the negative feedback. As far as this course is concerned, positive feedback is not in the syllabus, at least till this week. So op-amp should be in the negative feedback. And provided they are in the negative feedback, they are asking what should be the terminals of A and B in both the cases so that it is in negative feedback. Considering that, I have to find how they are connected to make them look like negative feedback. So anyway, it is provided this is also negative feedback, this is also negative feedback, but I am finding the terminals. So I am free to assume that this is negative feedback for finding the terminals of this. So we are assuming this is in negative feedback and we are applying the knowledge that we have learned, the concept that we have learned to find the terminals of this op-amp. So this is negative feedback. We are exciting its output voltage with the V test, and then we have found what are the terminals of A and B. Similarly, for calculating op-amp 2, we are free to assume this in negative feedback because that's how it is connected. Even though we don't know the terminals, it is connected in negative feedback. So now we have found out this terminal. So now this becomes the oral circuit, how it is connected. And then see, we are not using that this is negative terminal, this is positive terminal. But if it is connected in the negative feedback, then it is virtually shorted. So we are using the result of the connection. We are not using which is negative terminal, which is positive terminal. That will not benefit us in any sense. But if it is connected properly, then only we can assume that it is negative feedback and it is virtually shorted. So for that reason, we have to assume it is in the negative feedback. So Bhuvan has asked, sir, what is the advantage of negative feedback? So there are like that is a very generic question. If you see, negative feedback is there in everything, but at this point of time I cannot actually go in that much depth and make you understand because it needs control system knowledge as well. Okay, so maybe if I want to explain a little bit, if you see, if there is negative feedback, then what it happens is the output voltage is some gain times the input voltage, right? V naught is some k times into input voltage. So the output is some gain times input voltage. Whereas if it is connected in the positive feedback, then output will not be a finite value. Output will be either saturated to the positive value or it will be saturated to the negative value. So in a way, I can say that V naught, to make it stabilize, it should be connected in a negative feedback. That is one of the advantages of V naught. But main advantage why it should be negative feedback is in order to regulate the output voltage, say V naught, we need to connect this in the negative feedback, else it will be like incremented. Like the op-amp will get saturated if it is connected in the positive feedback. So that's how Schmidt trigger is made. So it will be either saturated to plus or it is saturated to minus if it is connected in the positive feedback. So at this point of time, I'm not assuming that you know control systems, because if you know control systems, then I can explain it in a better way. But for the timing, you can think that negative feedback systems are stable and output will be some gain. As we are using this as an amplifier, it should be connected in the negative feedback. Then for stable operation, output will be multiplying factor k times input voltage. If it is connected in the positive feedback, either the output will be saturated to positive VDD or it will be saturated to negative VDD. So at this uh, like instant, at this situation, you can assume that. But once you do control systems, if you are from electrical or instrumentation background, it will be there in third year. At that time, you will understand what is control and why negative feedback is used. Also in electronics, feedback is taught, why feedback is needed and how it is going to help. In detail, it will be taught there, why negative feedback is needed, what is the use of positive feedback. Even though positive feedback is unstable, it is used in few applications, but that is very few. But in our entire life, we have negative feedback. Negative feedback is everywhere. Like we can see control systems everywhere in our everyday life, and whenever there is a control systems, it will have a negative feedback. Starting from your mobile phones to vehicles to everywhere, everywhere there is negative feedback. But at this time, even if I explain, it will go over your head because you don't have controls background. So at this time, at this point of time, you can assume that negative feedback is needed for a stable operation, and in order to make it work like an amplifier, such that we notice sometimes some gain times the input voltage, it should be connected in the negative feedback. Also, if it is connected in the positive feedback, output could be either saturated to plus VDD or minus VDD, which are the supply voltages, which is what we are going to discuss now. So I'm not sure if that cleared your doubt, Bhuvan, but can you say at this time, like, is it clear, or do you want me to explain something more?
Sir, it's okay, sir.
It's okay, okay. But I'm not sure if which year are you from?
BTech first year, sir.
BTech first year. Okay, at this time, uh, negative feedback meaning like you cannot actually understand because you need to know some controls background. Then only you can actually understand. Negative feedback is something like this. So you can think in a way. Say I need my output voltage to be at some point. So what my circuit does is, if my output voltage is like not regulated, or say if there is a negative feedback mechanism, so if the output is going down, my circuit will make it increase. If my output is increasing, my circuit will make it uh, down, right? Say let me go back here to this initial circuit. Say my V naught is slightly increasing. Say V naught is slightly increasing. So what happens at the input? Input will slightly decrease because input difference VD is having a negative effect from the output, right? I know that VAB is some negative voltage into V naught, right? So if my V naught is slightly increasing, my input will slightly decrease. So if input is decreasing, output of the op-amp should also decrease, right? So say my cause is I have slightly increased V naught. Then what happens? My input will decrease because there is a negative effect, because uh, VD is negative times of V naught. So if V naught is increasing, input will decrease. But if the input decreases, output will also decrease. So if my cause is to increase the V naught, the effect is to decrease the V naught. So if I am increasing V naught, it is coming back, it is decreasing. Similarly, if I decrease the V naught, then the negative term here will make it increase. So output will be increased. So even if I do some change at the output, say I'm decreasing, the circuit is connected in such a way that it will make it increased. And if it is increased, it will make it decrease. So now let us go to positive feedback. Say there is only positive feedback. Now I am doing output, I am slightly increasing. As there is a positive feedback, V input will also slightly increase. Now, if input increases, output will further increase. If output increases, again the input will increase, and again the output increases, and again the input increase. So this will happen until V naught reaches the power supply voltage of the op amp, because we need some negative feedback to keep that output stabilized, because if it is increasing, the effect should be in such a way that the V naught should be decreased. So that's where this negative term is coming. But if it is positive feedback, if V naught increases, it increases the input voltage difference. It further increases V naught. It will further increase the input voltage difference, and it will further increase the V naughts. And this will keep on continue until the output voltage is saturated. But I need a stable V naught at the output. So for that stable performance, we need to connect it in the negative feedback. So the effect will oppose the cause, and V naught will be at a stable voltage. So I think that
Sir, what happens if it saturates?
so it saturates, then it will be either plus VDD or it is minus VDD. But that is not my aim, right? I want it to work as an amplifier. I don't want it to be at some voltage, right? I want the op-amp to work as an amplifier, and I want V0 to be K times V1. If I connect it in the negative feedback, even though if there is some change in the V0, that effect will reduce the cause, or it will diminish the cause. But if it is connected in the positive feedback, say some disturbance I have given at V0, it will get amplified and V0 will be either saturated to plus VDD or it will be saturated to minus VDD, which I don't want, because I want my amplifier to be working like a like stable performance. Even if there is some disturbance at the output, I want it to be diminished. I want to connect the circuit in a way so that it will be diminished. If it is connected in the positive feedback, then it will get amplified and it will get saturated, which I don't want. Maybe it is still not so clear, but at this point of time, you can think in this way. I want my output to be stable at some voltage. So even if there is some disturbance at that output, it needs to be diminished. So for that to be diminished, it should be connected in the negative feedback. If it is connected in the positive feedback, that will get amplified, and V naught will either go to plus VDD or it will go to minus VDD. So if I check the characteristics of op-amp V naught and VD, actually there is a saturation limit, which is plus VDD and minus VDD, which are the supply rails. So after reaching it, it will get saturated there. So we have plus VDD and minus VSS. So beyond that, it cannot be working as an amplifier. It will get saturated because that is coming from the practical constraints. So, and this gain is A naught. So within this region, it works like an amplifier. So if I have to make it work like an amplifier, then I have to what I have to make my input in this region. So basically my VD, my VD should be within this region, which is plus VDD by A naught and minus VSS by A naught. If my VD is in this region, then it will be in the amplifier region. So this is the condition that we have to maintain at the input so that it will not get saturated. Agree? So now what happens is, if there is a positive feedback, the disturbance will get amplified, the magnitude will increase and increase. And what happens? It will cross this, so output will get either saturated on the positive side or it gets saturated on the negative side. Clear? Whoever has asked.
Yes, sir.
Yeah. So now we'll solve one problem. 4, 5, 6, 7 we have solved. We'll solve this problem. So they're asking what is the maximum value of VP so that this will not get saturated. So I think this is which problem? I think problem number 5. So problem number 5. Okay. So first of all, let us consider this as V input VI. Current entering this is 0. Current entering this is 0. And this is grounded because it is virtually shorted here, right? Now I'll apply KCL. Current entering this terminal is same as current entering this terminal. So I'll get VI minus ground, so 0 by 1 kilo ohm is equals to 0 minus V naught by 3 kilo ohm, right? So now my V naught is minus 3 times VI. Agree? Agree? Hello?
Yes, sir.
Yeah. So now what I need to do, they're saying the op amp is not saturated. So condition is minus 12 less than V naught less than plus 12, which means minus 12 less than minus 3 Vi less than plus 12. So if you simplify this, I'll get minus 4 less than Vi less than 4, right? But they have given Vi as 1 volt plus Vp cos omega t. So if I substitute that, I'll get minus 4 less than 1 plus Vp cos omega t less than 4. So if you simplify this further, I'll get minus 3 less than Vp cos omega t less than 3. So from this, can you tell me what will be the maximum value of Vp so that it will be within this range? I know the result that minus 1 less than cos omega t less than 1. So from this, I can
Sir,
say
it's minus 5.
minus,
Sir, it's minus 5.
oh, sorry. Yeah, you are right. So this is minus 5, right? Okay. So it should be within this range. So now what will I be getting? I'll get Vp should be less than 3 because else it will be saturated
So
on the
VI
positive
was
side.
negative, sir, minus 3 VI. So the signs could have been reversed.
Yes. So here you will get two equations, right? One is minus 12 less than minus 3 Vi, which means uh, 4 greater than Vi. And the other equation you will be getting is minus 3 Vi is less than 12, which means Vi is greater than minus 4. So if you combine this, you will get this equation only. So I have just skipped that part.
Okay, sir.
Okay. Yeah. So this is minus 4 less than Vi less than 4. So if you do that, i- if Vp is more than 3, then it will be saturated on the positive side, which also we don't want. Even though negative side we have some space, or we can go till 5. So Vp should be less than 3. So what is the highest amplitude Vp? It is 3. So that's why they have given this. So is this clear?
Sir, cos function won't affect anything, sir.
Sir, sorry.
Cos function won't affect anything, sir.
No, because cos
Cos
omega t
function.
maximum value. So if you see, uh, if I divide this into two equations, minus 5 less than Vp cos omega t, right? And then Vp cos omega t is less than 3. So now the maximum value of this should be less than 3. What is the maximum value of this? It will be Vp maximum times cos omega t maximum should be less than 3. That means this maximum value is 1. So I'll get Vp maximum less than 3. Similarly, the minimum value of this should be greater than minus 5. And the minimum value of this is minus 1. So you'll get Vp to be minus 1, Vp greater than. So we'll get Vp to be less than 5. So you will get two equations, but you have to get the common solution from this and this. What is Vp is less than 3? Because it has to, Vp should satisfy both the equations. If Vp is greater than 3, it will not satisfy this equation. So Vp has to be less than 3 to satisfy these two equations. So at any condition, Vp cos omega t should be less than 3. So we'll consider the worst case, which is even when cos omega t is maximum, it should be less than 3. Even when cos omega t is minimum, it should be more than minus 5. That is clear?
Yes.
Yeah. So for the power supply of the op amp, there is plus VDD, minus VDD. It could be plus 12, minus 12, or plus 15, minus 15. Whatever they have considered, you have to consider in the while solving. So if the gain is, if the input is not within this range, then output will be saturated, because for a given gain and for a given power supply, this is the range of the input within which the op amp will work like an amplifier. Other than that, it will get saturated to plus VDD or minus VDD. So sometimes they ask what should be the input voltage range so that output will not get saturated. So we have used this condition, and we saw that there are two conditions. For it to not get saturated on the negative side, Vp should be less than 5. For it to not get saturated on the positive side, it should be Vp less than 3. But they have asked it should never be saturated. So we have to consider the common condition of this, which is Vp less than 3. So that's why Vp is less than 3. Okay, so that's how you solve the power supply questions, and when they ask what is the highest amplitude and everything. Okay, so today we have discussed about op-amp. We have initially started with the op-amp, what is the basic definition of op-amp, and then we have seen uh, negative feedback, how to find the negative feedback in a circuit, and we have seen if it has finite gain, how to find the overall gain of the op-amp, and we have seen if there are multiple op-amps, how to find the terminal so that it is in the negative feedback, and then we have also seen that there is power supply in the op-amp, and for it to not get saturated, what should be the input terminals. So there is less than a minute. If I think this meeting ends, if you don't have any queries, then we can end this session. Do you have any queries? There is less than a minute. If you have queries, then I'll restart it. If you don't have any queries, then we can end this session here. Any queries? No, sir. Okay, I wish you all the best for your weekend, and I'll see you in the next week. Good night, and all the best for your weekend. Again, we'll meet for week night. Good night. See you. Bye bye.